Hello students. Next we will look into Module 4. Module 4 has two sections, 4.1 and 4.2. I will be dealing with section 4.2. Section 4.2 basically deals with the electro-pneumatic as well as electro-hydraulic automation. Symbols basically. That means of the hydraulic and pneumatic components that we are having, we are trying to attach an electronic component to it so that it can be operated electronically. Section 4.1 basically deals with the pneumatic or the hydraulic circuits, whereas 4.2 deals with how these are electronically controlled. So let us look at the topics one by one. Now, in case of the electro-pneumatic or electro-hydraulic automation, you have to take care that for both the cases we are dealing with the same devices. Pneumatic is basically when the fluid is air, and hydraulic is mostly when the fluid is oil. That's the only difference. So here when I am putting bar to mean either it is electro-pneumatic or electro-hydraulic automation, I mean that you can use it for either pneumatic systems or you can use for hydraulic systems. Now, the control electrical devices, there are 7 that we are going to study here. Namely, first are the manually actuated push button switches, then the limit switches, then pressure switches, solenoids, the spelling here is wrong, now it is corrected. So solenoids, relays, timers and temperature switches. So these are the 7 electrical devices which are commonly used in electro-pneumatic or electro-hydraulic automation systems. These are the control electrical devices that we are going to study. The other devices that we are going to study are the proximity sensors and the electric counters. So now let us start with the manually actuated push button switches. Push button is a switch that is used to either open or close an electric control switch. Okay, and primarily it is used to start or stop the operation of a machinery. It can also be used when you want to manually override the system during emergencies. So it is basically a switch. How do you actuate the switch or the push button is by pushing the actuator to cause a set of contacts to either open or close. Okay, there are 2 types of push buttons. So basically you might have seen there is a push button something like this. Okay, on the device you press here and this button will be pressed down and something will happen. Either something will switch on or something may switch off. Okay, now there are 2 types. One is momentary push button and the second one is maintained contact or called as the detent push button. Momentary push button means you push it, you push the button will go down, and then again when you remove the pressure, the push button will come up. Whereas a detent push button is something when you apply the pressure to push it down, this will be pushed down, and when you take off your hand, it will remain pushed down. That means it will be pressed down. Then the second time again you apply a pressure, and then it will come off. And why does that happen? Because there is something like a detent. What is detent? Detent. What is detent? Detent is just like a index or just like a slot. For example, you might have seen certain pen. When you want to switch on the pen, you have to press on top. When you press on top, the switch of the pen will go down, and the pen will, the nib of the pen will come out, and you will be able to write. When you want to switch off, again you press and release the spring, or release the dent, or you release the detent, and that will again push this button up, and the nib of the pen will go inside, and you will be able to again not able to write. So that is basically what is called as a detent push button or maintain contact push button. Whereas the other push button, where you just press to push it down, to either switch it on or switch it off, and when you remove your hands, this will again jump back into position. That is called as a momentary push button. Now, according to the contact behavior, we can have three types of push button. Something that is normally open push button, or normally closed push button, or a changeover push button. Let us look at each one of them one by one. First is a normally open push button. What happens in the normally open push button? You can look at this particular structure. See, 3 is where the current is coming, 4 is where it is going, or it is supposed to go. And you can see that this contact that I am highlighting here, this contact is not touching this point, neither it is touching this point, because of which now no current is flowing from 3 all the way to 4. This is the push button, and you can see that the push button is basically attached to a spring. So this is the spring. This is the spring. So when you push the button down, what will happen is that 3 and 4 get connected. 3 and 4 get connected, and whatever is the case, the current will pass through. Okay, so this is the normal position, which is normally open, and when you push the button, for the moment so in normally closed case, what we are having is that there is a connection already between 1 and 2 because of the spring. Once you push the button down, the connection is open here and the spring is compressed. Then the spring, when you release the pressure here, then again it will go back to the normal position. So this is the normal position, this is the actuated position, and this is the symbol which is normally connected. Once you push this button down, the switch will open between 1 and 2. So normally it is closed. When you apply a pressure, it will open. Next is a changeover contact or a changeover push button. What is that? It is actually a combination of both normally open and normally closed. Okay, normally open and normally closed. See, what you can see here is, if you look carefully, you will see that normally the 1 and 2 are connected, whereas 1 and 4 are not connected. Why? Because the push button is in such a way that the contact between 1 and 2 is already there, whereas this is not pressed down. This contact is not pressed down, because of which between 1 and 4 there is no contact. Once you press the switch, what happens is that 1 and 2 get disconnected because a gap appears here, whereas this contact gets touched and 1 and 4 are now connected with each other. Now see here, the spring has got compressed as compared to this one. The spring is compressed. This is the actuated position. So in the normal position, 1 and 2 are connected. In the actuated position, 1 and 4 are connected. And this is the symbol for it. As you can see, normally 1 and 2 are connected. When you push the button, then this switch will flip here and 1 and 4 are getting connected. So this is the changeover push button. Next we look into limit switches. Limit switches are same as push button. They are same as push button, PB. But the difference is, whereas there is a person who operates push button manually, that means push button are manually actuated or manually operated, the limit switches are mechanically actuated. Now, what is the difference between mechanically actuating and manually actuating? Manually actuating means someone comes and pushes the button using his hands. Whereas mechanically actuated means there is, suppose there is a cylinder here which has a piston, and the piston can come out and you place a push button in front of that. Okay, so that when the time comes, you apply an electrical signal here, because of which the piston moves forward and pushes this button. So that is basically what is called as mechanically actuated. So limit switches are same as push button itself, but push buttons are manually actuated, whereas the limit switches are mechanically actuated. So how? Any switch that is actuated by the position of a fluid power component like a piston rod or a hydraulic motor shaft, that is termed as a limit switch. Okay. Now the limit switch provides an electrical signal for appropriate action. That means you are giving an electrical signal here, and that is basically what is making the mechanical actuation which pushes the button. Okay. They are basically classified as two types. One is lever actuated, another is spring loaded. Lever actuated is when you are actually slowly making this piston move and touch here. And spring loaded is something wherein, suppose you are having a spring in which you have attached a electromagnetic piston, and this spring is compressed, okay, due to some electrical signal that you have given. The spring is compressed and this is down. Now when you release the electrical signal, all of a sudden the spring suddenly expands and the piston moves forward very rapidly, and that is, the contact is operated rapidly in spring loaded, whereas in lever actuated, that means something like this, you are having what is called as the contact is operated slowly. Okay, now this is the structure of a limit switch, which is basically changeover. See, the previous push button changeover I will show. This was the push button changeover. You can see the shape of the thing is all same. There is a push button here. This was for the case of push button. The same structure of changeover is drawn in this one. The same structure is drawn, you can see. But now instead of push button, there is some lever which is actually moving, some mechanical component that is moving. Maybe what happens is that this one rotates. When this one rotates, this is slowly pushed down. So something like that is happening. Okay, so this is a limit switch. So internal structure is all the same. Similarly, you can do for the case of normally closed and normally open one also, the limit switches. Okay, now what is the difference in the schematic is, if you remember, for the case of push button, we had the push button drawn like this, whereas here it is showing a lever kind of thing, something like this. That is only difference in the schematic. When you look at this, you should understand that this is a push button, Whereas when you look at this, you should understand that it is a lever operated. Just to give you again a glimpse of push button. In push button, what we are having is a push switch, whereas here what we are having is a lever kind of thing. Next is a pressure switch. See what happens in a pressure switch is, just look at this particular switch here. You can see this diaphragm. This diaphragm is a flexible diaphragm. Below this there is a gap. Fluid or air can pass through this gap. Okay. Now in normal position what happens is, there is a piston attached to it. A piston means a small armature kind of thing is attached to it, which is connected to a spring. So this is the spring. Okay. And the armature or the rod is basically connected to a switch here, which actually is connecting between two ports, which are 4 and 2. Okay. So what happens is, when there is no pressure or there is no fluid in this particular chamber, there is no fluid here, the diaphragm is in this position. Whereas when some fluid enters there, because of the pressure with which the fluid is entering, the diaphragm will push up, because of which the rod will also push up. So see, previously the rod was here, now it has pushed up and reached all the way up to here. When it has reached up to here, what happened with that rod? This contact has shifted from 2 and gone and touched to 4. Now what happened because of that? See, previously the current that was coming through 1 was going out through 2, but now the current that is entering 1 is basically going out through 4. And why has that happened? That has happened because the diaphragm got shape change because of the pressure of the fluid that is there in this particular chamber. Now you can see, you can adjust how much pressure can be here by using this screw, which is called as the adjusting screw. See, when you adjust the screw in a certain way, you can change the pressure, because this gap is what is basically deciding how much it will move. So by changing that, you can actually adjust the level of pressure that should be here, that should happen here, so that the switch is made. Okay. So a pressure switch is an electro-pneumatic signal converter, which senses a change in pressure and opens or closes an electrical circuit. Which is the electrical circuit? This is the electrical circuit. Okay, so it either opens or closes an electrical circuit with the change in pressure, and when a predetermined pressure is reached. The main component is the diaphragms, which are used to sense the change of pressure and expand or contract in response. So this is the normal position where current is between 1 and 2. Once a pressure is there in this chamber, the connection is between 1 and 4. This is called as a pressure switch. The fourth electrical component or control electric device that we are going to study is solenoids, which is also called as electrically actuated directional control valve, or this directional control valve is written as directional control valve, which is written as a DCV. So whenever you see a DCV, you should understand that it is basically referring to directional control valve. There is a very good chance that they will mostly refer it to as DCV. Now, to understand the solenoid properly, there is a very good video. If you want to see with animation, it is available in this YouTube link. You can go to this particular link and try to look at that. It's a very good explanation. Anyway, see, when we say solenoids, you should understand that here this black thing that you see on this particular valve that is only the solenoid. Should understand that that is the only part that is the solenoid, whereas the remaining of the part is something that we already call as a valve or a directional control valve. So when we are saying electrically actuated directional control valve, this electrical actuation or electrically controlled is basically happening because of this solenoid. So it is actually electrically actuated DCV, which is also called as a solenoid, but originally the solenoid is only this particular portion. Similarly here also only this portion. So what is happening here is the movement that has to be done, the push button that has to be done is basically taken care of by an electrical method. What is that method? See, you all know that when we are taking a coil and when we are passing current through the particular coil, then in the center of the coil, magnetic field is generated. The magnetic field is generated. Now because of this magnetic field, which will have basically, it will be just like there is a magnet in here, and suppose the direction of the current is in such a way that this portion is basically north and this portion is basically south. Okay, and if suppose you are having an iron rod here, because of the presence of a magnetic field here, the iron rod will basically move up. Okay, or you can have a permanent magnet also here, such that this is south and this is north. Now because of which the south and south that we are having here, they will both oppose each other, because of which this may move down. So based on how you want to move the rod or the magnet inside, you can decide how the current or the direction of the current which should pass through the solenoid. The current passing through this wire enters, and this is basically the winding that we are having. Okay, this is basically the winding that we are having, and in between that there is the rod which basically moves either up or down. Now let us look at what is the directional control valve here. I have already told what is the electrical actuation. The electrical actuation is because of the solenoid. Now what is a direction control valve? Look at this particular direction control valve which is attached with a solenoid. Now where is the solenoid here? This black portion, this is the solenoid. Okay, this is the solenoid and these are the electrical connections of the solenoid. Whereas this whole thing is basically the valve or the directional control valve. That is the directional control valve. Okay, now this directional control valve has some openings. This is one opening, this is another opening, this is another opening, another one, and this is another one. All these openings are basically called as ports, or some textbooks they also are called as ways. Okay, so they are called as either ports or they are called as ways. Why is this called as ports? Because the fluid may enter or come out through these ports. So it may either enter or it may come out. Here also it may either go out or it may enter. Okay, that is based on how we are going to use this particular valve. Now this outer body is called as the housing, and here you can see there is a spring, and attached to that spring there is this thing which is basically called as the spool. This is called as the spool. You will find me using the word spool at many different places. Even last year in the course that we did, we had named it as a spool. Now what happens is this spool can be either moved front or back. We can move this spool front or back. Now when we apply some electric current to this solenoid, this spool may be pushed forward. It may be pushed forward. So when it is pushed forward, something happens to these ports that we will see later. But when we push this particular spool this spring gets compressed. This is the spring. This is the spring. And this spring gets compressed. And whenever the electrical contact is released here, that means whenever the electric current that we are giving, whenever we stop that electric current, what happens is the spool will now face no longer pressure here, because of which now the spring will push this spool back. Okay, now let us see what happens, how this works. So you are having the electrical connection. This is the solenoid. When the electrical connection is going and the coil is energized, here they have shown the coil to be energized by showing this yellow color. So when the coil is getting energized, the spool is pushed. And when that spool is pushed, you can see that these are like blocks. These blocks basically block this particular port, so nothing goes out or in from that particular port. Whereas here, there is a passageway for the air or the fluid to pass through this port, enter to this port and pass through this port. Okay, enter through this port and pass through this port. Whereas this port is also open so that some fluid can come back through this and go out. And you can see that the spring is basically compressed here. Let me write it properly. The spring is compressed here. Why? Because the electrical connections have been given to the solenoid, and this has pushed the spool. This is the spool. Okay, it has pushed the spool in such a way that now these ports are open to either pass the air if it's a pneumatic system, and pass the oil if it's a hydraulic system. Okay, now when we pass the oil, what happens in that? See, our major aim or our main aim might be to move this particular piston. Now this piston movement is basically based on if this chamber is getting filled up with air or oil, or this particular chamber is getting filled up. So if it's a pneumatic system, obviously this chamber will get filled up by air. This one also will be filled up by air. Whereas if it's a hydraulic system, instead of air, it will be oil. Now, if suppose we are pushing air through this in a pneumatic system, if we are suppose pushing air through this, then what will happen? The piston will basically move back. But if this has to move back, this air that is present here, that has to go out. That will go out through this particular pipe and it will go out through here. That's why the arrow is basically shown like this. Okay, so now what has happened is we have opened the pressurized air to enter through here so that the piston is moved back. Okay, and so when we are applying some particular energy, some particular pulse, or when we are applying some particular electrical signal, this one basically moves back. Okay, it can move all the way back. So that is what we are basically moving the piston. Now in the second case, suppose we want to move this piston in the forward direction. Suppose we want to move this piston in the forward direction, then what should happen? This should go out and this air should come through this way, isn't it? See, what has happened is, now when we have switched off, see previously we had switched on. Now when we are switching off the solenoid, the spool has basically come all the way back. The spool has come all the way back, because of which now this path and this path are basically connected, whereas this path and this path are basically connected. See, you should see here, there are three openings here. Am I correct? There are three openings here. This is one of the opening, this is the second opening, this is the third opening. Where is the pressurized air coming? The pressurized air is coming only in the center port. Here also there are three openings. This is the first opening, this is the second opening, this is the third opening, and the pressurized air is coming through the middle port itself. But now, because of the movement of the spool, the pressurized air is now entering this pipe. That means it is entering at the back of the chamber. And here, this is getting opened, because of which this particular piston will move in this direction. So it is for this particular motion of moving this piston here that we have changed the spool. So previously, when we had applied the pulse, the piston had moved in this direction. Now when we are switching off the pulse, the piston is moving in this direction. So as far as I am concerned, what is happening here is totally, I am not aware of. Suppose all I can see is that when I am giving a pulse, the piston will move towards this direction. Whenever I am switching off the pulse, the piston is moving in this direction. And all of this is happening because of this directional control valve. And now you know why is it called as a control valve, because it controls this. And why is it called as the directional control valve, because this particular spool basically controls in which direction the fluid or the air will move for the DCV to work. So now let us look at the explanation. A valve is a device that receives an external signal, which can be either mechanical, or it can be some fluid pilot signal, or it can be electrical. Now the solenoid is basically an electrical one, to release or stop or redirect the fluid that flows through it. That is basically what a valve is. Okay, our heart also has valve. And why is that valve? Because it allows the blood to flow only in one direction. Okay, so that is basically a valve. Now what is the function of a DCV or a directional control valve? It is to control the direction of the fluid in any hydraulic system. And how does it achieve this? This basically achieves by changing the position of internal movable part, which is basically the spool. So by changing the spool, the direction of the fluid is controlled in any hydraulic system. So what is the main purpose of DCV? It is to start, stop, accelerate, decelerate and change the direction of motion of a hydraulic actuator, basically a piston. So if you want to stop, or if you want to accelerate, or if you want to decelerate, or if you want to change the direction of motion of a hydraulic actuator like a piston, you basically use a DCV. Similarly, to permit the free flow from the pump to the reservoir at low pressure, again, what is this one? See, this is talking about this return line. See, this return line is basically applying no pressure. It is basically the air or the fluid that is here is basically draining out. So that is also with the help of this DCV, and that is what is basically being given in this particular statement, to permit the free flow from pump to the reservoir at low pressure. Okay. Then second is to vent the relief valve by either electrical or mechanical control, and next is to isolate the certain branch of a circuit. Okay, that means all of these functions are being done by the directional control valve. Then what is a solenoid? The solenoids form the interface between two parts of an electro-pneumatic system. See, up to 4.1 you were studying pneumatic control system or pneumatic system. Now 4.2 you are having electro-pneumatic system. So what is that? It is electro-pneumatic because there is a solenoid, that means electrically actuated. Up till when you are only studying pneumatic control system, you are only studying DCV. When you are studying an electro-pneumatic system, you are basically studying an electrically actuated DCV. Okay. So the main objective, what is the main objective of an electrically actuated DCV or a solenoid, is to basically control the fluid supply and extending and retracting the cylindrical drives. The cylinder drives are basically the piston. So to move the piston and to control the fluid supply, that is what is basically the main job of an electrically actuated DCV. Okay, now the DCVs are controlled with the aid of solenoids, and there can be two kinds. One is spring return valves and another is double solenoid valves. Now what are these, you will understand when you look at the next video. Okay, but basically there are two kinds of control. One is the spring return valves, another is the double solenoid valve. Now spring return is what we have actually seen here. Because of the spring, the return of the spring, this is how the spring got decompressed and returned to its original shape. So this is called as the return spring. This is called as the return spring because this spring helps the spool to return to its original position. It helps the spool to return to its original position. Sometimes it is also called as an offset spring. Okay, now the possible voltage levels to operate a solenoid are basically 12 volt. It can be small one, which are 12 volt DC or a 12 volt AC, or you are having a 12 volt AC. In case of 12 volt AC, it will be a 12 volt 50 or 60 hertz, or it can be even 24 volt 50 to 60 hertz. Like that, many different possibilities are there. So now when we look at this whole DCV or solenoid, so this is the solenoid and this is the DCV. So this DCV has how many ports? This is one port, then second, third, fourth and fifth port. Okay, so there are how many ports here? There are 5 ports here. Now how many positions are there? There are 2 positions. Which are the 2 positions? One is when you give a pulse to the solenoid and this is pushed. So this is the case when you give a pulse to the solenoid, this is pushed and the spring is compressed. So that is one of the position. And the first position is the normal position when no electrical signal is being given to the solenoid. The spool is in such a position that the spring is basically expanded, and now the power is basically going from here to here and the return is coming from here to here. That is the first position. And the second position, when you give an electrical pulse to the solenoid, the spool basically moves in this direction. The spool basically moves in this direction. So this whole thing gets moved and the spring is compressed, and now the pressurized fluid is flowing in this direction, whereas the return path is this. So this is the second position. So this particular directional control valve that we just now saw is having 5 ports or 5 ways and 2 position, and it is written as a 5-2 directional control valve. 5 is for 5 ports and 2 is for 2 position. Now schematically we can draw it in such a way. You can see that the spring is attached. In that case, when the spring is in the normal position, when the spring is relaxed, it is not compressed. When the spring is relaxed, in the relaxed state that we have drawn here, in that case, see, if you remember the numbering was like this. This is 1, okay, this is 2, if you remember the numbering, okay, this is 1, this is 2, then this is 3, this is 4, this is 5. I suppose I have written it correctly. No, this is 4 and 5, sorry. So this is 4, this is 3 and this is 5. Okay, now you know why we write like this number. I will teach you in the next video. But basically in this video what you should understand is, so this is position 1. In position 1 this thing is relaxed. So how I will draw it? I will draw a position in the square, and now in this particular situation 1 and 2 are connected, and that is drawn by this arrow. 4 and 5 are connected that is shown by this arrow, whereas 3 is not at all connected. So 3 is shown with the, as a stop sign, we show a T. Okay, we draw a T. So that T is in 3. Whereas in the second position, when the solenoid is working, so this is the shape of the solenoid, this thing that we see here, this is the solenoid. Okay, and this position, in this position we are having 1 here, which is, this is 1, this is 2, this is 3, this is 4, this is 5. Okay, so you can see 1 and 4 are connected. So here 1 and 4 are connected, whereas 2 and 3 are connected. So 2 and 3 are connected, and here it is returning back. That's why the arrow is in this direction. Here it is going up, so the direction of arrow is in this direction, whereas the port 5 is basically stopped, or it is closed. So we have drawn a T there, and this position is attached with a solenoid. Together, when we draw both of these together, that is the schematic diagram, and the schematic diagram basically looks like this. You can see just now I had shown for this position, I had shown for position 2, and this position I had shown for position 1. Now how to draw this and which all different kinds of shapes will come, and how it is an ISO designation, how to read the schematic, that we will see in the next video. Thank you.